Okay, I found a design flaw in the TRS-80 Model 1 and I want to just walk through this a little bit. So this is the schematics I created for the G revision, but all versions, including the Tech 1, has the same design flaw. So if we look at the edge connector, you can see that there is a test signal coming in, which is pulled up. This test signal is there to disconnect multiple things from various buses. So you can see 23 is connected to the test signal. The test signal comes out here. Let me highlight the path. It goes all the way around here to the CPU and the CPU gating circuitry. So looking at the CPU first, when we go into that, you can see test is coming in here and it goes to the bus request. What the bus request does is it will tell the CPU, I need access to the data and the control and the address bus. So please disconnect everything from the data, control, and address bus. This takes a little bit of time because the execution of the current instruction is still happening. And so it finishes all of that. And when it's done, it will trigger on the bus acknowledge that it is ready. However, this is not connected to anything. This is not even observed. So, but the circuit directly connects this to something called db out and db in. This is data bus in, data bus out. And this controls the buffers. Let's go to the buffers. So I'm going back out to the top. Again, we were just in the CPU. Now we can go into the CPU gating. In CPU gating, here you can see it comes in and it will turn off and on all of the address bus lines and all of the control bus. So these are also controlled by this one. These are connected to this one in the bottom. So with that, all of the, if this is pulled down, because it's a test, it needs to be pulled down. Since this is an inverter, and here's an inverter on the 3-state input, it will disconnect all of these buffers. That means the CPU loses complete control of the address bus, control bus, and the data bus. Here you can see also the db out and db in. That's exactly the same case here. Everything will be db in. That means it's only listening. It doesn't control the data bus. So that would work if we go back to the CPU. If this connection, so if we remove this connection here, and we would connect this one to the bus acknowledge, then this would work. This will make sure that the CPU has time enough to execute the current instruction, and then it tells all the buffers to disconnect. What is happening right now is when the test signal is triggered, bus request is requested, and everything is disconnected from the bus right at the moment. You don't wait until the bus is ready, the CPU is ready to do that. What happens here is anything that's read or written to the data bus will be corrupted because it's in the middle of the execution, and there's some likelihood that there's something going on the data bus, reading or writing. Either of these could corrupt the current state of the CPU and crashes it. If we let it go first and then only disconnect it afterwards when the CPU is ready, nothing of this will happen. This doesn't happen all the time, because not all the time something is connected, an instruction is executed to go on the data bus, read or write to it. And so in my estimate, 70 to 80% of requests, when you switch it on and off, the test signal, it doesn't actually crash, but it crashes on occasion. Exactly at the moment when the CPU is accessing the data bus, reading or writing to it. And so there's a quick hardware fix to do this, and I want to go over this and then want to show it in execution, how it was without it and how it is with it. To make sure everything is connected correctly, we also have to update the test signal here to bus acknowledge. So we need to listen to bus acknowledge, not the test signal, for the address and control signals. Let me zoom in a little bit to make this a bit more clear. Previously this was test, now it should be bus acknowledge. So we have to wait until the CPU is ready. These will automatically be covered because of the changes we did on the CPU side of things, where DB out and DB in was already converted and directly fed from the bus acknowledge. Okay, here I've connected this old Model 1 with the computer, with the monitor. I have the keyboard down here, and if I type in, that works. Keyboard is connected down here. This edge connector connects here. First this one for ground, and this one is the test signal. Right now it's unplugged, so it still works. I have here a probe for the oscilloscope, so I can see. And right now it's 264 Hertz, which is about 2-3 milliseconds, I think. So it's actually quite fast, and it works, right? Now, when I plug this in, nothing should happen. It should continue to work. Let me make sure I get this right here. And let's go to the computer. And you can see it corrupts immediately. Understandably, it will disconnect things 265 times a second, but this is the result of it. When I disconnect it, it works again. But everything is resetted. Now let's try with the hardware fix. Now a quick view on the hardware fix. So here there's a small cut for this trace. This is the test trace, which comes directly from the edge connector. A cut here, and then this is the bus request pin, and this pin is the bus acknowledge, which then connects to the rest of this. This then disconnects all the buffers. Now everything reconnected with the hardware fix. You can see that this still works, right? I have not plugged in the test signal yet, but you can see it's still 265, so nothing changed. So let me plug this in, and nothing should change. It's plugged in. Nothing changed here. It is connected here. Let me make sure it's all the way in. Yep. And even when I press the keyboard, it works. And that's because it connects and disconnects 265 times per second. And so it has enough time to answer keyboard requests. So this hardware fix works. This test signal feature was used by various devices, not too many, but one of the devices was, for example, the screen printer. So when you press the button, it would engage the test signal, read out the video RAM, and print out the video screen. When this happened, on occasion, things would crash. At least that's my expectation. I haven't seen this in real life though. But my guess is that this design flaw is partly attributable to the TRS-80 name. So having that fix, and this is actually a very quick and easy fix, you can make your Model 1 a lot more stable going forward.